As you probably noticed, there's a fair amount of hardware being set up over here, which is pretty exciting because I haven't seen many talks with hardware this year. Yeah, this is Simon, and he's...
Hello, everyone.
Hey, everybody. Hey, Simon. Simon's just playing with a video editor and all sorts of other bits and pieces. And he said, I just need another 30 seconds. So I'm just waffling until he sort of gives me the thumbs up and says I'm ready to go.
All right. I reckon we're getting pretty close.
Nearly, pretty close. All right. So Simon's talk is on circuit bending and 80's video editor, an exploration in open hardware.
Yep.
So let's give a very warm welcome to Simon Lees.
G'day, everyone. So this afternoon, we'll just wait for my... There we are. We're talking about circuit bending and ADO's video mixer. We're actually not. We're talking about a video editor, but that probably ties into my first couple of slides. So first things, it's always interesting to start a talk with how did we end up in a position with this much junk on a table? And so in my spare time, I like to mess around making music. It's not terribly good music, but I have fun. But rather than making my music better, to make things more interesting, I thought, what if I made wacky videos to go along with my synth music? And so thus this idea was kind of born. I was watching too much YouTube. I bought some things on eBay. Things happened. It kind of sat on the shelf for a long time. Then at SUSE, who I work for, we have this concept called Hack Week, where approximately once a year we are free to work on whatever we feel like for a week. And originally I was going to do something completely different with software modular synths and MIDI and sending that to OBS Studio to change plugins and stuff. But I woke up and I chose hardware. And I had hardware sitting around. And so thus this project started and consumed a week or two of my life. So first disclaimer, I am a qualified software engineer. I know basically nothing about electronics. What I say in this talk may and probably will be wrong. On the plus side, it means if you too do not know anything about hardware, you can still try this and have some fun. Disclaimer number 2, don't modify devices with 240 volts unless you actually really do know what you're doing. But I'll come back to that a bit later. There is capacitors, there is things that can kill you. Don't do it. We have a bit of a safety warning. The nature of these devices, they often make big flickering. That is a big screen. If you're photosensitive, I will have no problems with you going out now. At the same time, I will try and give you warnings before flickering things happen to the best of my ability, which will be probably a lot of the demos. So first I thought I would start looking at, if you want to create video art, there are kind of 4 ways you can go about and do it. 1, combining and modifying signals. Analog video is fun, you can just merge things together, and because the sync signal is mixed in with the picture signal, if you try and mix 2 videos together that aren't in sync, you will get weird stuff happening. The next one is by corrupting memory. By the late 80s, early 90s, a lot of little video enhancer devices that were popular with people who wanted to make their home videos better had a bit of a DSP in them, which read from a memory chip. And if you short together pins in the memory, sometimes you can do weird, fun things. The next one is by doing feedback, which I think I can give you an example of. Here is the first test of does everything work. I press that. I'll go into details about what I'm doing here later. But here I am holding what is meant to be a reversing camera for a car. If I pointed at the screen, you don't see very much. If I pointed at that screen, you still don't see very much. But the idea of feedback is you point video at video, you move it around, glitchy stuff happens. We may or may not come back to that later. The devices I've worked on weren't designed for doing feedback, so it's not something I can demonstrate, but it is a fun way of doing things. there are nice devices around for helping you do that. I'll talk about some of them later. So today, I wanted to start with a very simple circuit called Carl Klomp's Dirty Video Mixer. And basically, all we do is we take two analog video inputs, we shove them on either side of a potentiometer, and we blend between them. And as I said before, because your sync signals and so forth are all combined into one, you get weird glitchy effects, which, as you can see, it's a very simple circuit. I built this one last weekend in about an hour from parts I had lying around from JCar. Not all those soldering collections survived the flight, but we may as well plug it in and see what we get. You want that guy. All right, this is where the first flickering warning starts to come in. So, I'll give my video switcher a second. And so, I'll go through my setup later, but I have a set-top box that's looping between an image of a cross. I had some USB stick issues, and I don't have exactly what I wanted on there. But so at the moment, I have both these switches set to one side, which means they're both taking this input. I can now switch both these switches to the other side, and I have somehow ended up in the parental control of this other media player. But that's going to do for now. And so then when I can start at one side, and as I start to blend across, you see we have some, and at this point things get really interesting as it swaps sides. But if we come over here, we'll start with the other one. And you can see we can start to get that cross kind of in there. What I might do is, we might come back to this one for a second. And if I get this media player right, I'll edit a bunch of videos on here that didn't work. And I tell that one to, I think this one. The other problem is there is two media players here. They are both using the same remote control. And hopefully that will stay paused now. If it doesn't, I know I need to press the pause button one more time. But now we've fixed that, as you can see, we can kind of start to blend in the menu from the other set-top box. And you get to about here. And now we go, well, so far everything's been simple, but now, as you can see, we're kind of having issues. And everything is not as clean as we'd like. So I'm going to come back to my laptop now. So this is not cheap and easy. This starts out sounding cheap and easy. It kind of escalates. So the problem we were just seeing where we're kind of losing input, there is basically the issue here is we're making non-standard video signal. And if you have a really crappy video converter like this one, or even a lot of higher end ones, the minute you start to do something wacky, they will go, I don't understand the data you've sent me, I'm giving up, there's no signal here. So digital devices on their own aren't good enough. Even different analog devices will interpret the incorrect analog signals differently. So one solution to this is a CRT analog TV. My CRT TV is massive. It takes about 3 people to move. While I did bring a lot of junk here, a CRT TV was not on the cards. So we start to look for the next best option, which is something called a time-based corrector. And basically what that does is it generates its own sync signal and remaps the incoming video to that signal so that theoretically you don't lose sync. Some are better than others. Here we go. That's just what I talked about. I am going to get to open hardware eventually. There is an open hardware thing for doing this. Seems to be out of stock. I can't see much work happening on it in the recent time. So back in the 80s and 90s, these things were really expensive. I think some rack-mounted ones that do it really well still are really expensive. If you don't want really expensive, here are the two alternatives. I have a Kramer VP728 sitting here. Not all the Kramer units have a time-based corrector. This one does. Unfortunately, they're getting harder to find. This one I happened to purchase off eBay in the UK for about $200. They were originally used in conference centers like this one to swap between different people's videos. I have seen at least one of the slightly newer model in this conference center. So they're still around, but they were mostly common early 2000s. And so as we saw in this demo, some more flickering. When I get right to the middle of the knob and it's really trying to figure out which of the two sources sync, it should be caring about. This particular one starts to struggle a bit. So at home, normally I use this as my upscaler and converter, but normally I run a different time-based corrector in front of it, which is this Panasonic. There was one of these that came up on eBay the other week for a couple $100. But basically, it is in itself another video mixer. It's slightly newer than the one I'm working on. It had a full DSP. This one doesn't replicate the image as you would see it on a CRT TV, but it does make a lot of really cool, interesting, weird artifacts that look artistic and nice. And so I quite like it, and I think I've chucked a video demo of that at the end. So we'll come back to that. I only wanted to bring one video editor mixer thing on this trip. I thought that was already overkill, so it stayed at home. The other option, as I said, you can use a CRT TV, and you can point a camera at it, and that is another quite common way of capturing such video. The one thing to note, to avoid flickering, if you're shooting 50 Hertz, if you've got PAL, you need to align your camera's shutter rate to be the same as your refresh rate so you don't get flickering. The mobile phone camera on my last phone did this automatically. I haven't tried my current one, which makes life nicer and easier. And so that is your other solution. So now that we've talked a little bit about what I learnt once I'd built this thing and I was trying to make it work properly, let's talk about this video editor I have here, the JVC SX77. So here is the second page of the manual that tells you how to use this device. Basically, there is two inputs. You can plug a VCR into each input. You plug a third VCR into the output. You play video through this machine. You can fade to black. You can fade back in. When it works properly, you could add titles. And basically, if you wanted to take your home videos to the next level, you could use something like this to do so. Another video mixer I bought from a skydiving company who used to use a device like this to create all their skydiving videos for all their clients. And so, back to simple 80s technology. The next fun thing about this is talking about open hardware. The second link I got to when I started Googling this device to see what I could come up with was the service manual, which has complete schematics, complete part numbers. I have it here. We should have this on more devices. We keep going. And here's some nice big schematics, and then we've got block diagrams, which were even more useful. And that is the end. So an approach to circuit bending, if you don't have the full schematic, when I get it back, if you don't have the full schematic, an approach to circuit bending is you Google a bunch of the chips, you try to figure out where their power and grounds are, because running power into data lines is bad and will often lead to magic white smoke. And so you basically have to have the device running and try and short out weird things to find what works. Obviously, I found I had a whole circuit diagram, and so I could do something slightly more than that. I set out with a goal of, this is the notes I took from the original diagram. I basically wanted to build my one of the things I didn't like about this device, which I somewhat knew when I bought it, is this device isn't capable of mixing two audio signals together. It can just fade from, video signals. It can just fade from one video source to a background color. And so I thought, wouldn't it be fun if you tried to use a dirty video mixing concept to combine the two incoming signals and then try and feed them back into where the color generation circuit was, to see what would happen. And so at the top of that schematic, at the top of my rough schematic, you can see I have V1, V2, which are the two video inputs, and then the color circuit. And then I went through the schematic and I found that, I can probably actually find it on here, somewhere up in this region there is a D4, which is the diode after the video signal comes in for one of the video feeds, and I thought that would be a good place, so I took notes of it. I also took note, I found where the second video comes in. I found the monitor out because I thought I'd try feedback. It doesn't really work in this case because of various reasons, but I thought I'd give it a shot anyway. And so I ended up with 4 or 5 different things. I made my notes, and I also noted that there is a chip there that does color generation. We're going to come back to that a bit later, but that also looked interesting and worth looking at in the future. And so then I started pulling it apart and seeing what I could get to. This unit had already been circuit bent by someone else before. When I plugged it in, it was a flickery mess, so I had to deal with that a bit as well. But the key thing, remember I said don't circuit bend 240 volt devices unless you know what you're doing. While I don't really know what I'm doing, I know enough to know that all the 240 was, and I could confirm from the schematics that all the high voltage stuff was on these 2 PCBs, and I felt comfortable that I could extract these other 2 PCBs far enough away that I could work on them without being near high voltage stuff, and so I felt safe enough. If you don't know how to make that decision, or you're questionable about it, absolutely do not do this. Play with the passive one, go find a battery powered device, or something that only runs on 9 volt. And so this is a shot of the insides. As you can see from this photo, not every component on this device is still in ideal condition. There are some burn marks around parts of the PCB. I haven't actually figured out what is completely dead there and replaced it. So not everything was in perfect condition. I wasn't sure if anything was ever going to work properly, but then once I'd soldered my wires to the components, I did some CAD, cardboard aided design, and made myself a rough control panel. And this was about the end of my hack week time period. And so now you get to see the results. This has heaps of flickering. Be warned, I won't leave it up long, but that is basically where I got to after a week, and that is all I could figure out how to make it do. Have a break for a second while I talk. But then if you capture that at 5 frames per second, you get something that you could at least turn into a small GIF or use as an emote for Discord or something. So that was basically the fun of where I got to in Hack Week and what I could figure out with, at the time I only had one CRT TV, I didn't have any of this other fancy stuff. Sometime later I made it do this as well, which is basically the same thing but with my desktop. And once upon a time I even managed to make it do this. Cherish this image, I do not know how to make it do it again. But once it did that, it was really cool. I'm glad I recorded it. That is the end of the flickering images for now. So after that, once I got this working, I decided to keep playing with it and clean it up a fair bit. So I think I can even go like this. And if we get this box out the way, you can see my cardboard. That's funky. I guess there's audio coming through that camera. I'm going to stand away from the camera and talk. But you can see my cardboard aided design has been replaced with some 5-way selector switches and switches that I've just drilled into the top of the case. I removed most of the previous person's circuit bending, but there's one thing that doesn't do too much, and so it's the switch. It sits here. And that is where we cleaned it up to. And so now that's another internal shot. You can see here the method I've taken. I've cut off I desoldered the capacitor. I soldered a wire to the leg. To be safe and because I don't know what I'm doing, I tried to use diodes in lots of places where I thought they made sense. I don't know if they actually make sense and actually help anywhere, but that is what I tried. And so you can see on the right-hand green wire is the video signal coming out. The green wire coming back in is the signal coming back in. And then here is the switches that are now somewhat neatly soldered into the top. And finally, it's done. And I have too many video switches. But this is the combination I used to generate all the background images for these slides. Believe it or not, it took 3. So this device was generating all these random flickering things. I had another device that was mostly fading up to white so that it didn't look too overpowering and the slides were readable. And then a third one was using an image mask to create those blue things. So that was this setup. The demos I show you at the end will again be using this. Again, different video devices help with different things. The top video mixer there is from the 80's. It also does sync in a slightly hacky way, but if you run that before the time-based corrector, you seem to get better results than this other time-based corrector, which doesn't, because it always generates its own source. If your image is too narrow, you end up with a lot of flickering. So now we are going to attempt a proper live demo. So I need to plug this back in. It should also be noted I haven't tested this since the point in time that I got off a flight. And so it's possible that baggage handlers have damaged it or my poor packing has damaged it. It's also doesn't always work the same way every time I plug it in. So what we get is as good a big a guess to me as it is to you. But I think I did put a slide here. So for the sake of this demo, I have the reversing camera I showed before. Turns out laser set-top boxes are the cheapest off-the-shelf thing you can buy at the moment that will take a USB in and play media on it in an analog out way. I sometimes also use something from my laptop, but I was trying to keep it simpler. And then this bottom box that I'm using as my time-based corrector, I've also had my laptop plugged into it. It's got this camera plugged into it so that when I press this button, you are seeing, when we get there, you are seeing the device on the main screen, and then this camera's letting you see what I'm fiddling with. And so I'm going to better put the camera. I have a mess. Here we go. It's on a stick. normally so I can point it at things. I'll try and point it at this as well. Now if I take bypass off, we could get anything. And we are getting a lot of flickering. Sometimes if you bring the faders down. Where you're seeing the green lines is somewhere where the other corrector seems to manage better. And so we can turn the wipe on, which will help. Turn on all these things. And then, so if I go to the program, we either get nothing some days. Oh, we need input 2, that's right. One of the things that surprised me from my schematics is input 2 works vastly differently to input 1. You can see here we're still getting a lot of flickering. Oh, we're back. So now I'll talk briefly about the future plans I have for this thing. Obviously, sometimes there's a lot of flickering. Some days it looks nice. Some days I can do fun things with the... I'll go to this camera. That shouldn't break anything. Some days... so the way this color selection works for the back color is basically just a ladder chain of different voltages, and there's that one IC that takes 2 voltage inputs and outputs the background color. To me, that kind of pairs nicely with stereo audio and making some fun, cool, glitchy things by trying to run audio into that circuit. One of the things I was able to learn from, again, having the schematic, if I didn't have the schematic, I would have tried this and blown everything up, because on this particular board, the audio after the audio fader is all between minus 12 volts and 0 volts, whereas the color generation chip is running on 0 to 3 volts. And so I actually have to do some circuit design now and convert those voltages so it doesn't break anything. I also thought about doing this. I need my slides on the screen if I'm going to talk about them. I also thought about doing this one weekend, but then I decided it was safest not to blow this up before I gave a conference talk on it. And so now coming back to open source, circuit bending in open source is an interesting thing. I've seen other circuit bend devices like this. Often people are very secretive about their designs and what they've done. If I thought what I'd done was actually useful and replicatable on another one of these, maybe I would have got around to publishing what I've changed better. But I also get I am too lazy to write documentation for a fun project. So I kind of get that side of it. But there are a couple of, if you're interested in video art, there are a couple of other good video projects around. How to make a crappy video synth for $10. His words, not mine. This is a cool, in the same way that an audio synth generates audio, a video synth generates video. This is a very cool design. He's basically taken a VGA tester to generate, and then you can feed whatever you want into the red, blue, and green lines of the VGA, like sine waves, square waves, whatever you feel like, to generate different patterns. He sells PCBs for these. I have bought the PCBs. They are sitting in my big pile of things that I should build one day. So I haven't actually got around to testing them yet. But that was one. I have lost my other slide. Let's see if it's under here. Oh, here we are. This uses a VGA converter, and it uses the memory shorting techniques to make cool glitch arts. There's a bunch of stuff on YouTube if you're more interested in it. And I think, to finish up this talk, let's look at 2 clips that I recorded at home earlier where I had everything and I wasn't likely to crash the video system. So this is the first one. There's a video loop running in the background. You can see that here at the bottom goes random colors like that. That is the way the other time-based corrector handles signals being too small. And it looks kind of cool, but if you look on a CRT, you get different glitches. So this is one. I can get it to do something like this reasonably reliably. And so that's good because one of my aims was to have something that I had at least some level of control over, that I could do something meaningful with. If it's just doing random stuff all the time, it's very hard to drive, make anything meaningful. But I got to learn a lot. So then this other one, this is the closest I've ever seen to it working as intended. It is blending the video signal with the color generation signal. And where's the play button gone? And so you can see I'm changing around the color correction knobs and we're getting different color effects. I can use the wipe to wipe in and out a different color. This is where if I can get it to do this reliably, feeding audio in to change the colors as well, I think would be fun. And then I would actually have something usable here for what I was aiming for, other than for learning purposes. And so I may as well, I think that's towards the end of my talk, other than obviously I think that people making modern equipment should do better jobs of publishing service manuals with full documentation so that we can circumvent their stuff more easily. But I guess I should also say thank you to Sousa for both giving me now I've got some flickering, for both giving me a week to work on this silly little project. I should say the hack week before I developed a new product. And so I very much felt like doing not work stuff for this hack week. So thanks to them for giving me a week to work on it. They also helped fund my travel here to this conference. So a big thanks to them. We are employing kernel engineers, a couple of packages, some security people. If you're looking for a job, come and chat to me afterwards. And beyond that, is there any questions?
Questions? Yes, right. This gentleman up here.
So earlier this morning I attended a talk on kernel fuzzing, and now I've attended this circuit bending, and then it kind of occurred to me, I'm sure it's occurred to someone else, like could you kind of combine this, like take off a whole bunch of outputs and like automate kind of testing them all? Is that something people have like done, or do you think that would be doable?
I guess to some level you could test something like I have in my bag over there. I have a HDMI to USB converter, and this would be a perfect test case for that. But in terms of generating other random sources,
I more meant like to you like obviously you were trying to figure out if you connect this to this what works. I was thinking like could you just like pick 50 random things and like automate figuring out what was cool to then like more permanently bend it. That's kind of what I guess I meant, yeah.
It doesn't do the same thing every time I turn it on. It also depends greatly on the output resolutions of the video sources and which converters I'm using for some reason. It also depends on which of my other devices I plug it into. And so far, in an ideal world, I recorded this one day because I finally got it doing something cool, and I figured I should record it while I was doing it so I could show it at the conference talk once I knew I was talking about it. But if I could get it to do this predictably and reliably, I would be a very happy person.
Hey, thanks for the talk. Video synth is something I'm really into. I've got a very close friend who also does it. Just shameless plug of him.
Yep.
If you have web access, he has a web app on his website, chrispetro.net, which essentially would be a great demonstration, kind of like a lot of the techniques it uses. He's essentially built this from scratch. chrispetro.net. Sorry, it was. I was going to phrase it as a question. Would you be willing to bring it up? Yeah.
Yep.
So
that is cool. In fact, in order to simplify this setup, and because I'm using my HDMI output to feed the slides, often I will take the HDMI feed out of my laptop and feed it into this. There is also another freeware program I use that is not open source that actually converts video to, oh, here we go, converts video to audio and back. And I've had some fun with that, which was going to be my, I think we've got one at the back, which if it was open sourced would be another perfect talk for this conference, but
Since you've got all those cables sort of spread everywhere and looks
Yes.
like even more on your setup at home, do you have a favorite analog video connector? Or an opinion on SCART?
I would like to give a big shout out to JCar, because JCar will still sell me a SCART to composite connector, and that has been useful. My general opinion on the topic for this is, given how much I'm butchering the video signal paths inside the unit, I could use the crappiest cables ever outside the unit, and it's probably not going to make it any worse than what I'm doing with this. But I do, out of habit, I got this nice cable from, I'm going to stop the flickering now. I got a nice cable with one of the things I bought, and that tends to be my general output to the upscaler as much as anything else, so I can remember that that's the cable I need to plug into the last thing.
You mentioned, thanks for your talk, Simon. You mentioned like audio. Are you having any? Do you have any plans to do some sort of audio sync so that it might be possible to sync, like beat sync to audio sources, like music? I mean.
Yep. So the idea of audio into the color generation circuit was a way of trying to do exactly that and get some beats and some movement happening in time with music. With my synth setup at home, it's very easy for me to take just the kick drum output and just some other output and feed those two signals into the left and right and do something like that. So yes, that is part of the future plan. It is also something I do in the software land a lot. That again isn't quite, it's freeware, it's not open, so I decided to talk for another day, but I'll happily talk to you about it afterwards. Right, well, thank you very much, everyone. Sorry to the AV guys for crashing their system.